Okay. So you're doing section 8.8 and 9.1. So section 8.8. So section 8.8 deals with the complex, the use of complex system. Complex system. Now, if we recall, if we have the square root of negative, let's say b, the square root of negative b. So if n is, let's just, before we go to this, we can say if we are given, let's say n here, and then negative b here. If n equals to even, if n is even and it is greater or equals to 2, greater, let's say n is greater or equals to 2, and is even, greater or equals to 2 and is even, then the square root of a negative, the root of that negative will be a complex, So we know that the square root of -1 is equals to I, and this I is the imaginary unit. The I is the imaginary unit. So the square root of -1 is giving us the I. And the I is the imaginary unit. So the square of I, which is I, same as I, is equals to -1. The square of I is equals to -1. So basically, it's the same as raising this one to, so this is like I raised to 1/2 equals to -1 raised to 1/2 equals to I. So if you want to remove this square here, then this half here, then we multiply both sides by 2. So it will be -1 equals to I squared. So I squared is equals to -1. Okay. Okay, now, after knowing this, then we can now solve an example. So let's start from the square root of, let's say the square root of -6. The square root of -6. So if we, before we go to this, if we remember, say, if you're given the square root of a, b, so this is similar to the square root of a, square root of what? B, right? So it is the same as square root of a, square root of b. So in our case here, the square root of -6 is the same as the square root of -1 times the square root of 6. square root of -1 times the square root of 6. Then we know that the square root of -1 is what? I. So basically this is equals to I, the square root of 6. I, the square root of 6. Another example, the square root of -40. The square root of -40. So here again, we can write this one as square root of -1, square root of 40. Also, we can still write this one as the square root of -1, the square root of 4, that is what? It's 10. Then we can also write this as the square root of -1, the square root of 4, and the square root of what? 10. Okay. So finally, this is the square root of -1 is I, the square root of 4 is 2, and the square root of 10.
Certainly.
So we get something like this. Something else. Okay, so what we are doing is a complex system. So when we say the square root of -1 is similar to I. Okay, and this I is an imaginary unit. So this is like an imaginary number. So the square root of I is a -1 I. So again, I squared is equals to -1. So you multiply 2 i's, then you get -1. So it is similar to just squaring this, and then you square this. So equals to -1.
Does it have to be square root of -1?
Yeah, so the square root of -1 is equals to I.
Because the square root of 1 is just 1, right?
The square root of 1, of course, is equals to 1. But if there is a negative there, as long as if you have n here and you have a negative here, let's say -a, then as long as n is greater or equals to 2 and this n is even, then that root will be a complex unit. So it will give you a complex number. It will give you a complex number. Okay, so so we did an example. So we say the square root of -6 is similar to the square root of 1, -1, the square root of what? 6, right? Okay, so we know that the square root of -1 is equals to what? I, the square root of what? 6. I, the square root of 6. So if you recall this, if you recall the square root of a, b is equals to the square root of a, the square root of what? B, right?
Mm-hmm.
Yeah. So it is similar to this. So the square root of -6 is similar to the square root of -1 multiplied by the square root of 6. Okay, so we did another example. So we say the square root of -40 is similar to the square root of -1, the square root of what? 40. Okay. And this is also equals to the square root of -1, the square root of 4, the square root of what? 10. Because 4 times 10 is 40. Then finally, we can write this as the square root of -1 is I, the square root of 4 is 2. So you get 2I, the square root of what? The square root of 10. 2I, the square root. So another example, if you have the square root of, let's say, 172, the square root of 172. So the square root of 172 is similar to the square root of -1, the square root of what? 172. Okay. So when you divide by 2, you get what? 80.
86, right?
86, right? When you divide by 2 again, you get what? 43, right?
Yeah.
So that means it will be equals to the square root of -1, the square root of 4, the square root of what? 43. Okay? Because 4 times 43 is 172. So this is equals to the square root of -1 is I, the square root of 4 is 2, so 2I, the square root of what? 43. I, the square root of 43. Okay, finally, in this case, because we're not going to do a lot of things on complex, because this is a course by itself. This is a course that I'm doing right now. So this is just basics, introduction of complex numbers. So another example, if you're given the square root of -114, just the same one. The same way. So the square root of what? -1, the square root of. So 114. If you divide by 2, what do you get? 51. 57. So you cannot get the square root. So it should just be what? I, the square root of 1. So I, the square root of 1. So we are not going to go to much details about this complex. We are not going to do the addition of complex number, multiplication of complex, or something like that. I don't think it's relevant to this point. So as long as you've known that the square root of -1 is an imaginary unit. So let me just give you a brief introduction about complex. So a complex number is a number of the form A plus BI. So this is a complex number. A complex number. So this A is a real part. And this B is the imaginary part. So that is just the imaginary part. So when it comes to addition, multiplication, subtraction, or something like that, then just like the way we are adding numbers, then you add the real, you add the complex part separately. So it's like collecting the like terms. So if you're adding, let's say you're adding A plus BI plus C plus DI, then you just add the real parts, which is A plus C, and then plus the complex part, which is I, B plus 1, plus D. So you add the real and the imaginary part. When you're multiplying again, when you multiply, now the I and I, what do you get? So let's say you're multiplying AI multiplied by BI, you get what? AB. I and I is what?
I squared.
I squared, which is what?
Negative one.
So it will be negative 8. So the all is you don't have to know, but you can. You want to know that it is okay. All right, so let me not confuse you more. Let's go to the next chapter, which is chapter 9. Chapter 9. So, and we're going to start from section 9.1, where this one is so quadratic equations using square root property. Using the square root property. Solving quadratic equations using the square root property. Now, if we are given x squared equals to 9, and then we are told to solve this. So what is the value of x? So what is the value of x? 3, right? Yeah. So this is similar to x squared minus 1 equals to 0, right? And this one is a product of difference of two squares. So this is similar to x minus 3, x plus 1, which is equals to 0. Now, using the zero product property, x minus 3 equals to 0, or x plus 3 equals to what? 0. So that means x equals to 3 or minus what? Minus 3. X equals to 3 or minus 3. So therefore, the square root of x squared is the same as plus or minus 3. So x squared is similar to plus or minus the square root of what? The square root of 9. X squared. Sorry. X equals to plus or minus the square root of 9. And this one is giving us what? Plus or minus 3. Plus or minus 3. So therefore, x squared equals to k is equals to, this one is similar to x equals to plus or minus the square root of k plus or minus the square root of k. So this is the square root property, the square root property. So example, for example, for example, 3q squared equals to minus 3. 3q squared equals to minus 3. Using the square root property, what is the value of q? So what do you do first? So what you do first is, first of all, you make sure this what you're looking for is on one side, and the other ones are on the other side. So then, in this case, what do you do here? You divide both sides by what? 3 first. So you divide both sides by 3. Because what is only affecting, what is the square root of q? The only square root there which is being affected is the q, right? So we divide by 3, we divide by 3. So q square equals to what? Minus 1. Minus 1. Now, using the square root property, then q will be equals to plus or minus the square root of what? Negative 1, right? Plus or minus the square root of. So we know the square root of negative 1 is what? I. So therefore, q equals to plus or minus I. Q equals to plus or minus I.
How can I be positive?
It can be positive.
Because I thought I was the square root of negative, not like.
So we know that I is equals to the square root of what? Negative 1. Okay? So negative I square, or when you square this, negative I. So what do you get?
Negative 1.
So you get negative I times what? Negative I, right? So negative and negative positive. So I and I is what? Negative what?
Negative 1.
Yep.
So negative I squared would be positive.
So negative I square is, it is still similar to negative. So look, so the square root of negative 1 is the same as plus or minus the square root, plus or minus I. Okay? Because using the what do you call the square root property, then we know that negative I times negative I is similar to this I, and this I is positive, right?
Right.
So which will be I squared, which is equal to what? Negative 1. I times I is equal to what? Negative 1 also. So it is the same thing.
Okay.
Yeah. So the property is, we should use the square root property.
Oh, that's
So the square root property will say, let's say x, the square root of x is similar to plus or minus, let's say 8 or something like that. Yeah. So we what am I writing? X equals to plus or minus the square root of 8. If we know that the square root of that, so
right.
The square of this, I'm sorry. So if x squared equals to 8, then to get the value of x, then it will be x equals to plus or minus the square root of 8. Plus or minus I square root of 8. So it doesn't matter whether this one is negative or positive.
I see.
Yeah. Okay, so another example, use the square root property to solve the quadratic equation 6c squared plus 1018 equals to 0. 6c squared plus 18 equals to 0 using the square root property. So we can take the value of 18 to the other side. So 6c squared equals to what? Minus 18, right? So c squared equals to minus 3, right? So this using the square root property, we know that c will now be equals to plus or minus the square root of what? -3. And then now C equals to plus or minus I, the root of what? The root of 3. I, the root of 3. So in Newton, if you ask something like this, then you need to separate the values by a comma. So C is the same as negative the root of 3 or the root of 3, I the root of 3. So those are the values for C. Okay, another one. This is 3c squared equals to -15. So using the square root property, then c squared equals to -1. 5. So c equals to plus or minus the square root of 5. So c equals to -I, the root of 5, or I, the root of 1. The root of 5. I, the root of 5.
Oh, so what you're saying, in Newton, we can't put plus or minus sign.
What's that?
In Newton, we can't put a plus or minus sign.
I don't think it's there. I don't think it's there. Okay, so another example. Let's say 4y squared plus 60 equals to 100. 4y squared plus 60 equals to 100. So what is the value of y? So again, you check all those values to the other side. So 4y squared equals to 100 minus what? 60. 4y squared equals to what? 40. Y squared equals to what? 10. So what is y? So y equals to plus or minus the square root of what? Square root of 10. So in Newton, we just write minus the square root of 10, the square root of 10. Square root of 10.
So it's only ever going to have an I in front of it when it's the square root of it, right?
What?
You're only ever going to put like I.
Yeah, so long as there is a negative, if there was a negative there, then it could have been the square root of -10, which is the same as I, the square root of 10, right?
Mhm.
And then the other one is minus I, the square root of 10. Okay. Another example here. Minus 3a plus 2 squared equals to 64. Minus 3a plus 2 squared equals to 64. Solve this one. So what do? You remove the square, right?
Mhm.
So this is similar to minus 3 plus 2 equals to plus or minus what? The square root of 64, right?
It's 3A.
8. Yeah. So minus 3a plus 2 equals to 8, and minus 3a plus 2 equals to minus 8. So we get two values there. So we have the plus 8, and then we have the minus 8. Okay?
I see.
So we have the plus 8 and minus 8. So in the first one, then it will be what? Minus 3a equals to what? 6, right? So a will be equals to minus 2. How about the second one? So our second one is minus 3a equals to minus a minus 2 is minus 10. So 3a equals to 10. So a equals to 10 all over what? All over 3. So we have two values here. So a equals to minus 2 and a equals to 10 all over 3. So another example, q plus 5 all over 4 square plus 7 equals minus 18. So how do you solve this? How do you solve this? So first of all, you take all those values to the other side. So the 7, you take it to the other side. So q plus 5 all over 4 square equals to what? Minus 18 minus 7. So negative 2. Negative 2. Then now you remove the what? The square. So using the square root property, so q plus 5 all over 4 equals to plus or minus the square root of minus 25. So basically this is q plus 5 all over 4 equals plus or minus 5 what? 5i plus or minus 5i. So therefore, take this to the other side. So q equals, when you take this one here, then it becomes what? So it will be minus 5 all over 4 plus or minus what? 5 minus 5 all over 4 plus 4 minus 5. So in Newton, then it will be minus 5 all over 4 plus 5i, comma, minus 5 all over 4 minus what? 5i. Okay? That's clear? Yeah, so you take this one to the other side. So when you take this one here, then it will be minus. So minus 5 plus or minus. Okay. Another example, let's say you're given z plus 4 all over 3 squared equals to minus 3. So this is similar to the previous one. This is similar to the previous one. So this is the same as z plus 4 all over 3 equals to plus or minus the square root of what? Minus 3. So z plus 4 all over 3 equals to plus or minus 3 what? 3i. So z equals to minus 4 all over 3 plus or minus 3i plus or minus 3i. So when you take this one here, then it becomes minus. And then you add or minus 3i. So in Newton, you put the what? The comma. So that and that. So basically, this is the 4 over 3 plus 3i and 4 all over 3 minus 3i. So these are the standard forms of, so this is a standard form of complex number. This is a standard form of complex number. So this is the real part, and this one is the imaginary part. So the complex form of a real number we shall write as a plus or minus bi. So that one is the complex form of standard form of a complex number. All right, so the last example on this section. So d square plus 10d plus 25 equals to minus 18. So d square plus 10d plus 25 equals to minus 18. Equals to minus 18. So what do you do? So first of all, you can either leave minus 18 in the other side and solve this one, or you can bring this one to this side. But in our case, we can just solve this one first. So when you solve d square plus 10d plus 25, so what are the roots there? So it's similar to d square plus 5d plus 5d. So when you group these ones, then two. Okay. Any question up to there?
Can we go back to the previous example? That question.
Which one? The
one before this one. The Z.
This?
Yeah. So, no, it's the Z plus 4 with 3. Not this one.
Z plus, it was the Z plus 4/3 squared equals 3.
This one?
Yes. So my question is like, so when you get rid of the square, you get like the square root of -3.
Mhm.
Why wouldn't it be like just I? It's like the square root.
Oh, I made a mistake. I don't know why you did not tell me. So this is I, the square root of what? 3.
Okay.
So this is I, the square root of 3. Okay? Yeah, you need to correct that. So this is I. This one is 4. So Z plus 4 all over 3 square equals to minus 3. So Z plus 4 all over 3 equals to plus or minus the square root of minus 3. So Z plus 4 all over 3 equals to plus or minus I, the square root of 3. So Z equals to 4 all over 3 minus plus or minus I. The root of 3. All right, any other question? Okay, so if there is no other question, so make sure you do your homework. Deadline is today. I'm gonna extend the 2 weeks. Okay, so I will put all your grades in model so that you can check.
And you say you're extended the whole lot?
No, I extended, so I'm not extending it anymore. So the ones which are due, like the ones which are supposed to be done today, I think today or two. The one which we are doing right now is due, I think, tomorrow or Monday.
There's one due last night.
Yeah, so I'll check on it.
Okay.
Yeah, so from next week, I'm not extending. So make sure you do your homework. So, anyway,
Are we having quiz this weekend?
yeah, there is a quiz this weekend. I already graded your last quiz.
Mhm.
Oh, see you guys.